Today we are interviewing Cameron Williamson, who works for IGS based up near Dundee. And he is somebody who is currently building a vertical farm, or sorry, I say currently, has built a vertical farm and is going to talk to us today about what the idea behind it was, his background, and what brought him to engineering. So I'm going to stop talking now, and I'm going to hand over to Cameron because his presentation is certainly a lot more interesting than anything I have to say this afternoon. So Cameron, over to you.
Excellent, thank you. Just sort out Zoom. There we go.
There we go, perfect.
Right, thank you very much for joining me this afternoon, everybody. This is my presentation, Farm Up Engineering a Vertical Farm. So my name is Cameron Williamson. I'm a mechanical and electrical engineer with Intelligent Growth Solutions, or IGS. And I'm a GTL system owner, which means I am responsible for a section of our product, which is the growth tray, or GTL. I live in Clackmannanshire in Scotland with my wife and my two daughters. And I think that's worth noting that I live in Clackmannanshire. I grew up here as well. And I certainly, growing up and at school in Clackmannanshire, I wasn't aware of any engineering or anything really sciencey at all happening around here. And definitely wouldn't have thought that it was something that I could do growing up to become an engineer and still live in the area that I grew up in and that I like. So I think it's good to point out that with modern remote working, you can be an engineer wherever you are, which is a brilliant thing. So on my background, I've always loved engineering, really, even when I didn't know that's what it was called. My favorite toys were things like Lego and Kinects and this kind of crazy stuff I've got on the screen here called Capsula. I especially loved motorized versions. So this one here, it's got little gears through it. You hook it all up and you can put propellers and wheels and motors on, and it can drive along, or it can, with the propeller, it can float along in your bath. And I had a lot of fun doing similar things to that, and sort of playing with my with like a microscope and a telescope and things like that. And it meant that going into high school, where you get a lot more variety of classes, my favorites were those where I got to be creative. So art, chemistry, technological studies, craft and design, and it was this. Particularly with chemistry and tech studies, it was the chance to create things whilst learning how things work in general. I've always found that really interesting. And tech studies in particular covered most types of engineering that I have used in my career, doing woodworking and metalworking in the craft and design aspect, getting to learn how to take an idea, design how you're going to implement it, and then actually do it by cutting up some bits of wood or some bits of metal and making a picture frame or a TV stand for your PlayStation or whatever it might be. And that I really loved that. And sort of other interesting things, getting to do a bit of pneumatics. I didn't really know anything about that before. So using pressurized air to move cylinders and other actuators around, I just thought that was amazing. I think in particular it was programming. I expect you're probably all lucky enough to have done a bit of programming already, but for me, I didn't get to do programming at all until probably second or maybe third year of high school, and I just thought it was fantastic. They gave us this little chip called a PIC micro, which is these tiny old-fashioned looking little microchips, and I could only do really basic stuff with them, but having a little button and some LEDs, I could write a program, press a button, and traffic lights came on and a green man lit up, essentially. And it's so simple, but it was the aspect of taking it out, imagining something in my head, writing it down and making it happen in real life, I just thought was brilliant. So tech studies, getting to do that in a whole variety of different things and learning about sort of engineering principles, it meant that what is often a very difficult decision in school in general is deciding what you want to do when you finish. For me, was easy because this was what I was best at, and it was what I enjoyed the most. So I found a degree called robotics and cybertronics at Heriot-Watt University, which let me do mechanical engineering, but with electrical, electronics, computer science, with programming, get a bit of do a bit of everything again, which was fantastic, and it suited what I like to do. I didn't want to have to narrow myself down to one type of engineering too soon. And as part of that course, in my 4th year, I had a module where we were splinter groups of 5, and each group was assigned a local company where you were given a fairly simple task to do. And for us, it was doing a bit of programming again, for designing some test equipment. And it felt complicated at the time. In reality, it was probably fairly simple, but we worked quite hard at it to make sure we did a good job, delivered it to the customer, and they were happy. And it meant that in my 5th and final year of my degree, when I was giving my final presentations, the guy who was running that project at McTaggart Scott was there, and we were able to, he remembered me. I'd obviously made a good impression, and off the back of that, I got an interview and then a job as a research and development R&D engineer, which again, I was lucky, was getting to be quite a broad range of engineering in R&D there, which was perfect for me. It was working, so it's naval defense. And yeah, looking at this slide, I don't think growing up I ever imagined when I was making this crazy looking toy that could float on water and propel itself along that I would be making equipment that would be used on a Royal Navy ship that you can see here. It's the Type 26, and the helicopter handling system that I designed and created is being fitted to that ship, which I certainly wouldn't have imagined that in school, that was something I would get to do. And as well as that, while I was working there, I got opportunities to do all sorts of interesting things. I got to go into a prototype submarine in South Korea, which was pretty interesting, to stand on the deck of the Royal Navy's new aircraft carrier in Rosyth. And a pretty cool and surprising one was when I was doing some work with McTaggart Scott for a different company in Sweden. They were launching their brand new fighter jet for the first time ever. And as I was there, I got to go stand on the runway with my earplugs in and watch a fighter jet take off for its first ever flight right in front of me, which was a pretty incredible thing to get to do. And again, certainly not what I expected to be getting to do as my job growing up in Clackmannanshire. Off the back of that, I was lucky enough to be approached by IGS to come and have a tour of their vertical farm. And I knew a little bit about it, but not a lot. I was enough to be interested. But when I got there and saw the site and got to see it properly, I immediately wanted to go work for them, and was fortunate enough to get that opportunity as a mechanical and electrical engineer. So I will now talk a bit more detail about IGS. So IGS was created to solve a problem. And the problem is really 3 parts. First of all, land. So globally, we don't have enough land for farming. And that causes all sorts of problems, food shortages, etc. But because we don't have enough already and the population is increasing, that's going to become more of an issue. And that puts a lot of pressure on people and companies and governments to try and solve that. And what a lot of people end up doing is things like deforestation, so chopping down forests so they can have more fields so that they can feed people. And that obviously has devastating consequences for the environment and for sort of nature in those areas and around the world. Alternatively, over cultivation. So this is when farmers use their fields too much or too intensively, and it results in degradation of the soil. So the soil that you're wanting to grow these plants out of becomes less good at growing plants, really. It can become sandy, or the nutrients aren't able to circulate properly, and you end up either not being able to use the field, or certainly not being able to use the field as well, which exacerbates the problem, makes everything worse. And then on top of that, climate change means that in some areas they get too much rain where they didn't used to, or they now don't get enough rain, and that makes the problems even worse. So that areas where you could historically grow food, now you can't. Which leads on to the second part of the problem, which is water. So growing up in the UK and especially in Scotland, you maybe wouldn't necessarily consider, you maybe wouldn't really think this, but water is a very valuable resource. And it's something, especially in hotter countries, that you really have to deal with as a huge cost when you're farming. And in conventional farming, in fields, the farmer will irrigate their crops by pouring water on them, essentially. And because there's nothing to capture it, that water will run off and go back into the rivers and the seas where it came from, meaning to the farmer that water is lost. And they now have to get more water to keep their plants growing healthily. And a byproduct of that is the water that runs off can often carry chemicals of some kind, so fertilizer or pesticides into the seas and the rivers that it's going to, which can really harm the natural environment where it's going. And third is energy. So conventional farming uses a lot of fossil fuels. So tractors and other farm vehicles predominantly or mostly run off diesel, which is obviously not great for the environment, but much worse than that is the transportation. So in the UK, if you want to eat a strawberry, for example, in winter, the only way to get that from conventional farming is to import it from overseas. So to get a huge shipping container ship bringing this over, and they are really damaging to the environment because of the amount of fuel that they consume. And that's certainly something we want to try and avoid. So with all that in mind, IGS was founded. It was founded by Sir Henry Ackroyd, who was a farmer, and an engineer, Dave Scott. And they combined their knowledge. So Sir Henry Ackroyd has been a farmer for a very long time, a very successful farmer, and Dave Scott's a very successful engineer in industrial automation. So moving things around warehouses and things like that for storing things. So they combined their knowledge to find a way to grow plants indoors using LEDs, and to do that efficiently all year round. And that's what you can see on this slide is IGS's facility up in Invergary near Dundee. And this is a 10-meter tall building, so it's pretty big. It's taller than a two-story house, but inside it can hold 4 growth towers. So at the moment we've got 3 in there, and we're deciding on whether or not to build the 4th one in the 4th space just now, or to make the building even bigger. If I go to the next slide, you can see what's inside. So this, as I said before, that building holds 4 growth towers, and this is 1 growth tower you can see here. That's on the image here. It's 9 meters tall, but we can go up to 12 meters tall, which is pretty big. And that allows us to grow crops on trays in a controlled environment all year round. And I'm going to show you here a little clip of what it looks like inside the tower to give you kind of perspective. It's 9 meters. I think it's hard to know quite how big that is, and the previous image doesn't really do it justice, but this is what it feels like standing inside one of these growth towers and looking up at the trays. And if I then go to the next one, you can see what that looks like in reality. So obviously the big difference here is all the light. So all of these growth trays, or GTLs, there are 54 of them in this 9-meter tower. Each of those growth trays is an individual, is its own growing environment. So they have to control the light. So they have lines of LEDs on the underside. They have to control the temperature and humidity, and they have to control the water that's going to the plants. So to start with the light, all these LED lights that you can see on the bottom there, they're sort of white dots, which is actually a cluster of 5 LEDs. So the first 3 or 4 really is green, blue, and we have 2 red LEDs. And if you have all of them turned on, you get white light. And we can adjust those to give plants what they would see in nature. But obviously the sun doesn't just produce the light that we can see. It produces light on either side of that spectrum. If you've done light spectrum in your science classes yet, you'll know that light is split into the colors of the rainbows. We call it a spectrum. So one end is red and at the other end it's violet. And if you go beyond the violet end, you get ultraviolet, so UV, which is obviously a lot of the light that comes to the sun that gives you sunburn. Whereas if you go to the other end, there's infrared. And infrared we also can't see, and that's what your TV remote uses. It flashes infrared light to control your television. But if you go just between red and infrared, you get far red. And if we put the LED, the far red LED, which is our 5th LED, on at full power, you can sort of see, with the human eye, you can see that the diode is like the bulb is like glowing, but you can't really see light coming out of it necessarily. But the plants react really well to this. The combination of these 5 different LEDs in different ratios does all sorts of different things to plants. So you can encourage plants to grow taller by using more far red, for example. And you can do things like with some plants, you can encourage them to flower or to produce fruits by changing the different light combinations. So we do a lot of research up at our crop research centre near Dundee to figure out the best way to use all of these to control the plants, to make them grow the most nutritious and the tastiest and the quickest and the cheapest way that we can to get all those aspects covered. The next step, temperature and humidity. So temperature and humidity we control together with our air conditioning system. It basically pulls air out of the middle of that tower and then sets the temperature and the humidity, which is the amount of water in the air, to the level we want, and then delivers it individually to each of those growth trays to give each of those GTLs its correct temperature and humidity. But the next thing we need to worry about is watering. So in the image that you can see here, where you were standing, where it looked like you were standing in that little GIF, is a lift shaft. So that moves, there's a lift which moves up and down between these 2 lines of growth trays, and it pulls these trays out one at a time into the middle to the opening so that the farmer can harvest them or can do whatever needs to be done, and then they get put back in again. But this lift also does other things. So the first other thing it does is water the crops. So it actually has a water jet on each of the 4 corners. If I move to the next slide, when you need to water crops, it moves into position and it sprays water at high pressure tubes, which then direct it as where we want it around the growth tray to water the crops. And you'll see it sort of distributes it quite nicely underneath the plants so that it doesn't splash on the leaves and the soil can absorb it. And then the final part of that GIF is the water draining out the bottom. So this is called ebb and flood, where you put a load of water in and then it slowly drains away. And most of the time the plants are sitting without water around them. They've just got the water that's held in their little bit of soil or whatever it is they're growing in. The other thing that the lift does is it has cameras. It has 2 cameras, one for the front of the tower, one for the back. And that allows us to monitor the crops and keep an eye on what they're doing without having to climb all the way to the top of the 9-meter tower or bring the trays down every single time you want to look at them. So it lets us do cool things like make this little video. So this is some basil that's growing, and it takes the lift took a photo every single day while it was growing. So this is probably about 24 days or so. That's usually about what we have to grow basil for to get it ready. And yeah, when you put them all together, you can see this lovely video of basil growing. But we also do really useful things with this. But first of all, it lets you have a quick check and make sure everything is doing what it should do. But it also, we've got clever software running which analyzes this, and it can feed back to the user to tell them if the plants are growing as well as they should. So you can do things by look at how many leaves you can see and how long it's been growing and check that that's all correct. So to go back to the problems that I talked about at the beginning, this is how we at IGS aim to solve some of these problems. So land, you don't need to worry about growing it in a field. You can grow anywhere that you can get water, electricity, and internet. So rather than growing in a field, you can grow in an old abandoned car park, or you can grow anywhere that you can put a building with water, electricity, and internet. We can grow, and that means that you can use, instead of using that field for growing these crops, you can grow something else, or you can return that field to nature. You can grow trees or something else to allow wildlife and nature to take that space back. Secondly, on to water. So we recycle our water. all the water that we put into the tower essentially gets recycled and captured and put back in. Only the water that really leaves the site is in the plants themselves. So you saw the little clip of the water draining out. That goes through a drain system. It gets pumped back to the top where our main water tank is. It gets recycled and cleaned to make sure it's not got any bacteria or anything else that's growing in it. And then it gets its nutrients topped up. So it gets fertilizer or whatever it needs put back in, and it can get used to water the next batch of plants. We even capture water from the air. So when plants essentially breathe, they release water into the air, and that increases the humidity. And if we need the humidity to be lower, we pull some of that water out of the air, capture it, put it back into the same tank to reuse again, and keep the level where we want it. And finally, energy. So our farms run off, they only use electricity, which means they can be entirely renewable, which is excellent, obviously. It does rely on us having the rest of the infrastructure sorted out across our country, so getting a lot more wind turbines and things like that. But when they're there, we're ready to be fully renewable. And importantly, and secondly, is that our plants don't need to travel. So you can build one of these farms, one of our vertical farms, next to, we say, the point of consumption. So whether that is your supermarket could have a tower, a farm right next to it, so that when you want to go buy whatever it is they're growing there, they can have control of it, they can grow the crops, and they can put it straight into the warehouse and straight onto the shop floor for people to buy. That is really, really beneficial ecologically, so that you don't waste all this fuel. And finally, I want to talk a bit about what I actually do in my job. So as a mechanical engineer, I'm a mechanical and electrical engineer, although most of my time at IGS I've been doing mechanical work. Most of what that entails is seeing a problem and finding a solution for it. So the process I would normally do, so this is something that I've made fairly recently. It's a little probe housing so that we can put some sensors somewhere. And the first step would be specifications. So that's writing down exactly what the problem is and exactly what you want your solution to do, which is very important to do that first, so you know that you're designing the right thing. Then next, you would do sketches and design. So draw out some rough ideas of how you would maybe solve this, and do some calculations to confirm if you're right and if it'll do what you want it to do. And then on to the design. I've got an image on the screen here where I've modeled it on the computer. This is the sort of the final version of this design after it's gone through all the sketches and everything else. I then needed to prototype it because it would be expensive to make hundreds of these all in one go. So I wanted to make a few to make sure I was right and did what I wanted it to. So the best way for this part was to 3D print it. So the GIF that's moving on the screen there is my 3D printing software that I was using. So I import this 3D model that I've made, put a few settings in, and it automatically plans out how the 3D printer will make it. Some of you might even have had a go at a 3D printer potentially, but it's pretty impressive, and it lets you basically, it just has a little nozzle in it. Leaves a little layer of, it prints layer by layer, as you can see here, and it makes it out of plastic. The third image there is that probe housing printed. So you can kind of see it's a bit wibbly wobbly at the top. You can see the lines are maybe a bit uneven, but that's absolutely fine. It was a sort of set on a fast prototype mode, so I can get an answer quickly, and it'll tell us if it works, and then we can make a high quality one later. And the final slide, the final image here, shows that probe housing, again, still the 3D printed prototype, but with the printed circuit board, so the components that are actually doing all the sensing that I was looking to support in place. And that's all I have for you. Thank you very much for listening, and on to the questions.
Brilliant. Thank you so much for that, Cameron. That was, honestly, I was sitting looking at that tower and trying to figure out that is really, really tall. And as we've been going through, lots of questions have been starting to appear in the Q&A and in the chat as well. So if you've got questions, start asking them now. I will try, and I know people use both the chat and the Q&A, so I'm going to try and alternate between the two. So I'll start with the first question that landed into the Q&A, which is about your biggest highlight. So what's been the biggest highlight of your career so far, would you say?
So thinking back on my time at McTaggart Scott, I sort of said all the cool things that I got to do, and they were great. But the biggest highlight probably was making a new noise and vibration system. So because we were designing stuff for submarines and aircraft carriers and other sort of Navy equipment that needs to be really quiet so the other boats can't find them, how much they shake and rattle is really, really important. So I worked at McTaggart Scott and developed a testing setup, basically, and a bit of software that would allow us to put things called accelerometers, which a lot of you might have heard of, that's how your phone knows if it's moving. You basically get fancy versions of those and stick them all over your equipment, and the program that I made analyzed that really reliably, and that's still in use at McTaggart Scott, even though I've moved on now, and that was pretty cool. I think, and then at IGS now, it's kind of hard to say what the highlight is because it's been such a rush. When I joined, it was still a startup company. There were about 20 people. We're now at over 150 in 2.5 years, and it's pretty fast change. And being involved in that is just being at IGS, honestly, is probably the biggest highlight. Just getting to see all of this change so quickly and being able to do something good. Getting to I really enjoyed my time at McTaggart Scott, but defense isn't really an industry that I wanted to be working in. Whereas this agriculture stuff is fantastic. There's sort of no question about it being a good thing. So that's great.
Brilliant. The next question that we've got is about how far can virtual farming go? So is it something that could be used right across the UK? That's the question, but I suppose that the add-on would be, is it usable all around the world?
Yes, so our objective is to have vertical farms on every continent around the world. There is really no limit to where you put it. The building is insulated, so you chuck it wherever you want, and we control the temperature inside and the humidity and everything else to be wherever it would be. We would like to see our vertical farms everywhere, and not doing everything, but doing a lot. We're never going to replace all farming, and that may well be one of the other questions. I'm not distracting myself by having them up, but we're not looking to replace conventional farming. We're looking to be an extra component for it. So you're never realistically going to use one of our towers to grow wheat and things like that, but you can use them very well to do the things that are kind of obvious for doing it. If you're in this sort of area, are things like basil, lettuce, salads, leafy green, little things like that. They grow quite quickly, they're tasty, they're expensive, they're ideal. But more interestingly, recently we've been doing some trials growing trees. So Scottish government and lots of governments across the world have made big promises to plant millions of trees a year, and there aren't that many seedlings ready to go. So we've been able to grow with our vertical towers. We can grow from seed to little trees that are about that high, ready to get planted out in 2 or 3 weeks, and we can grow thousands of them per GTL in a go. So that's pretty cool.
Wow. We've had 2 questions come in from 2 different people, but I think they're both pretty much the same. And it's around how long did it take to build, to set it all up? Or how long did it take you to build the first tower? And how long does it take now?
So the first tower, so when I joined the company, they had the first tower with just one growth tower inside, growing for about 1.5 years already. It was another 6 months before we built the next 2, which we built. We had the building already, but the actual towers inside, from building them to having them finished, was maybe a month and a half to get those 2 done. And we're currently building for one of our customers in Paris, in France, and we're putting up 1 tower every 2 or 3 weeks at the moment with them. So it's impressive turnaround compared to from the start to the finish. And that's a lot of what I've done since joining IGS. As I said, that the first tower was already there, but it's finding a way to take this amazing technology and make it so that you can produce it reliably, cheaply, quickly, but still with the same quality.
Okay. And what's, in your experience so far, what was the most challenging thing to grow vertically?
So one, so I'm very interested in it, and I like to have a look at the farming, whenever I possibly can, so that I know what I'm designing for. But I'm still an engineer rather than a biologist. But I know that the potatoes are one that I think people that doesn't seem like one that you would be able to grow plants, would be able to grow in the tower. But potatoes, because they grow in the soil, they grow really big, they're really big and heavy, they take a long time. But we found that we could grow seed potatoes, so grow very tiny little potato seeds into small potatoes that are ready to go into a field. That would normally take several months to do that. We can do it in a matter of a few weeks, and they're ready to go. So that there were some challenges with that originally, putting too much soil in and making things too heavy and things like that. But we were able to solve it, and find a way to add a really valuable type of plant that we can grow in a really beneficial, economically, so for money, way that we could find. So that was a good one.
Brilliant. And the next question we've got is about how many different crops can you grow in the farm?
So we can pretty much grow anything you want, but we maybe be a bit expensive to do it. So I said you're never going to be growing wheat in our towers. You could, but where those slots are about 30 centimeters, normally, we can change it, but normally they're about 30 centimeters apart. So a normal ruler that you'd get in school, which means anything that's taller than that, you have to take out the tray above to grow bigger. So things like wheat that might grow taller than me, you'd have to use up a good chunk of your tower just growing this one bit of wheat, which would be smarter to grow in a field. But we can do it. But to grow well and to grow economically, which is obviously what people in business and farmers are, business people, is what they care about. I think last count was over 200 that we can grow economically. Wow. And a lot of those will be variations of similar things, but they're all different crops that we've been able to do. And it's that there's an expanding team up in Invergowrie who are constantly doing trials to try and improve the range of crops that we can grow economically, and making them tastier and better and whatever else.
Brilliant. And the next question we've got is around, question is, does it harm the environment?
So obviously you're building these towers out of metal. So that metal has to be mined out of the ground. But the important thing is that they're designed to last 20 plus years. So you can use a very small patch of land that is that couldn't be used for anything. It could be somewhere that they've knocked down a big factory. You're never going to be able to put houses there. You're never going to be able to grow anything useful there. We can use that land, which is not otherwise useful, and we can build our towers. And I would say that we're a huge net positive because of that. So overall, I would say we're a good thing environmentally. That everything we do as humans has a cost to the environment, but hopefully it has more of a benefit to the environment than it has a cost. And I think we definitely fall in that category.
Brilliant. And then I know you were talking about the heat lamps and the lights and the impact of the different lights. So the next question is around, do the heat lamps affect how the plants grow?
So we don't actually use heat lamps. We use the lights themselves. So LED lights are very efficient. They're much better than, so old-fashioned lights that you'd have on your ceiling get really hot for a little bit of light, whereas LEDs in modern lights and on your phone screen and your computer screen and anything else, those are LEDs, they make a lot of light and only a little bit of heat. But because we are controlling our growth environment so well, that little bit of heat that they make is enough for us. So we are able to, what we actually do is we cool down the electronics that's running these LEDs and all of the stuff, and that they get a bit warm. We cool them down, and the air that's cooled them down comes out the right temperature for the plants. So to say, does it affect the plants? It does affect the plants, but it's in a positive way. So we need that heat for the plants to be able to grow at the best that they can. And it will depend on the different plant. There'll be a different temperature, but most plants that you're growing will be between 18 and maybe 24 degrees Celsius. So that's the target we'll be hitting at the right point for that plant.
Okay. And how many people will work in a farm?
So working in a farm, so there's two sides to it. So there's the vertical farm itself, so the towers where the plants are growing. Once we're finished improving or finishing our automation aspect of it, which is having robots to move things around instead of people moving things around, you essentially won't need any people. The only people you would need there would be someone to do maintenance. So if something broke, somebody would have to go in and fix it, but that would be it. So looking after the plants, everything will be automated. You will still need people for the time being, depending on that's our expertise. The other expertise is what the farmer does, and that's how you pick and harvest and process and do whatever else it is you need to do with your plants. And that can be automated, so there's not many people, but in some countries and some places that's not automated. You just hire lots of people to chop up your plants and do whatever it is you need to do. So for the harvesting side, we're sort of able to be automated probably more easily than normal farming, as long as you've got the automation equipment. But from the other side, there should essentially be nobody needed.
Brilliant. And then the next question we're being asked, are these products now in our supermarkets?
So not in the UK. So the only IGS vertical farms in the UK at the moment are in our test site up in Invergowrie, and we just grow for our research. We did, at the start of COVID, we were donating a whole load of food to local food banks so that they could help feed people when there was trouble getting food around. But that's IGS really aren't growers. We're making the technology and we're selling it to farmers to do the growing. But in Paris, where we've got the customer I was talking about before, they are currently growing for supermarkets. I don't know specifically which ones, but maybe if you're in the right part of Paris, you might be able to find something grown by Jungle, and you could find something grown in one of these towers. They are also growing flowers for the perfume industry over there. So again, I don't know who they're selling to yet, but potentially some perfume that you buy might contain some part of a lily that was grown in one of our growth towers fairly soon.
Wow, that's really cool. And the next questions we've got are a bit more about you, and so the first question we've got is, what inspired you to become an engineer?
So I guess it was indecision, me not being able to make my mind up, because all I wanted to do really, like I just loved engineering. And I was saying before, I like playing with all these engineering toys. I just wanted to do that. And when it got to the end of high school and I was supposed to be deciding what I wanted to do, whether I wanted to get a job, whether I wanted to go to uni, didn't really know. But I knew I liked doing engineering. So when it wasn't actually me, it was somebody else found this course that I ended up doing and showed it to me. It was just like, well, that's what I'm going to do. That's it. Like it felt like such a perfect fit for what I wanted to do, particularly because the course robotics and cybertronics, it had a lot more aspects of creativity, of getting to make robots that you can do anything with that. That's probably what inspired me to actually commit, because alternatively I might have gone into art and there would have been a whole different life for me. But I'm really glad that I went the engineering way.
And when you were at school, the next question's about your favorite subjects. Which ones did you enjoy the most?
So as I just said in that question, really it was everything creative. So art I really liked. Chemistry, I was a big fan of chemistry as well, and then tech studies. Surprisingly, I didn't really like maths very much at school. I think I did okay at it. I got reasonably good grades, not amazing, but good enough. But actually, now that I'm an engineer and I use maths all the time, but I only have to touch the types of maths that I use for my job. I really like that. Whereas I think what I didn't like about it at school was having to learn maths and not really getting what you were learning it for. So I learned it because I had to, whereas now I use maths because it's essential for my job, but it's the kind of maths that I really surprisingly enjoy. And I did definitely, when I was at school, I did not think I would say that I would enjoy maths, but I definitely do now.
Brilliant. And what don't you enjoy about your job?
So I guess right now, as I said before, we were a startup company. So we went from 20 people to 150 people in about 2.5 years, and we're still increasing that number a lot. So at the beginning, when I joined, I was the third engineer at the company, maybe fourth. So we're such a small team, you always knew what each other were doing, and you didn't really have any rules about what was happening because there were a few, you sort of trusted each other and you could do it. Whereas now that we have more engineers in the company than we had people in the company back then. So right now it's figuring out processes and I guess rules so that we're all doing things the same way and we all know what each other are doing. And it's really important, but it's probably not quite as fun as doing the actual engineering part.
And the next question that's linked to that as well is, have you ever been in trouble? Have you ever done something and you've been in trouble at work?
No, not that I can think of. I think at work, well, I would say at positive companies, if you do something wrong, the most important thing really is being able to own up to it. And I'm sure there are plenty of companies that people work for where you wouldn't feel happy to own up to your mistakes. I've made plenty of mistakes. I haven't necessarily done anything wrong because when I've made the mistake, I've come forward with it and shared it with other members of the team, and we found out ways to fix it. Whereas if I hadn't told people that for example, I had put a hole in the wrong place. So there's this little metal plate that I was making, and I measured something to put the holes in the right place so I could mount this piece of equipment on it, and I made a mistake. I put one of the holes in the wrong place, and I got 100 of these cut out of metal, and it came back, and I put the hole in the wrong place, and I could have probably tried to hide that, and that definitely would have been wrong, and it would have made the whole fixing it more expensive and everything. What actually happened was I was a bit embarrassed, told them that I did it, that I made a mistake, and we fixed it, and that was that. So yeah, I think plenty of mistakes, but nothing wrong so far. Hopefully it stays that way.
Brilliant. And the next question we've got is, if somebody wants to become an engineer going forwards, what subjects would you recommend that they make sure they're paying attention to when they're in primary and secondary school?
So as much as I said I didn't find it that fun at school, maths is a really important one. You don't need to be the best in the class, but you need to have a good idea of the basics. So when you get into more complicated maths, you're probably not going to use the really complicated stuff in your job unless you're doing something very specific. But I use simple maths all the time in my job. So it's really important to have a good idea of that. But aside from that, technological studies, if you have it at your school or equivalent, and physics. Physics is, I only did a little bit of physics at school because I kind of thought that tech studies would cover most of it. And actually, it probably meant I had to learn some things at university that I probably would have learned at school if I'd done physics. So that's a really big one, because knowing the rules and the laws of how nature works, so gravity and how strong things are and everything like that, is probably the most important thing after maths that you can learn. And physics is probably the best for that.
Perfect. And we're down to the last two questions, and they're two really nice questions to sort of finish off on. So the first one is around, what do you do when something goes wrong? So when you're designing something, it doesn't quite go the way it should do. How do you keep yourself going, and what do you do?
So owning up to it, first of all, and speaking to your colleagues or your manager or whoever it is you're working with, it does make you feel bad. You know, like what I've made, as I said, I've made a few mistakes. I've done things wrong. Fortunately, none of them have been particularly bad or expensive to fix, but it does make you feel bad. It's like, well, I should have done that better, you know. And I think for me, it made me feel bad afterwards, and then it made me make sure I didn't do it again. So all those little things that I did wrong, or mistakes that I made, have made me now a much better engineer, because I know I'm not going to make that specific mistake again. You know, I would be looking to make sure I don't do that thing again. So getting past feeling a bit sorry for yourself, and then using it to make you a better engineer or a better scientist, I think is the important thing.
Brilliant. And then the last question to finish off today with, we've got, what advice would you have for somebody who's potentially going to become an engineer?
I would say do it. Definitely do it. It's great. If you have inclination, if you want to be an engineer, there will be a type of engineering that will suit you. And while I've said math is really important, even if you're not that great at maths, there will be a type of engineering you will be able to do. Not all engineers go through university. You know, if you're not necessarily a high achiever, there are other ways to get into engineering. And if you are getting great grades and you're a high achiever, then that's great. Make sure that you're doing practical things as well as just learning. So I think making sure you're a bit balanced and then just going for it, and knowing that there are so many types of engineering out there, and realistically, if you're interested, you will be able to find one that suits you.
Perfect. Brilliant. Well, thank you very much, Cameron. That's the end of the questions for today. And thank you to the schools who've joined us for this afternoon session. I don't know about you, but I've definitely found it really, really interesting. And I'm really appreciative that you've shared your experiences and your job with us, and how you look at the world and found a problem and found the solution to it as well. So thank you everyone for joining us. Remember, the deadline for your entries to come back to us is March 23rd. We've already got so many schools entries landing with us here. It is building up. There are stacks of papers growing around us with all your fantastic ideas on, and we're loving starting to look at them. Don't forget, all of next week, we've got an interview every single day at 10:30 and at 1:30. Just head to leadertheward.com to see who's coming up next. But for now, for this afternoon, Cameron, thank you so much for your time, and we'll see you all again next week. Bye-bye now.
Great. Thank you very much. Bye-bye, everybody.